Now let's just see the questions that are related with polynomials in one variable. So the question number 1 says that which of the following expressions are polynomials in one variable. So the very first part is 4x square minus 3x plus of 7. The next one is y square plus of square root 2, and the third one is y plus 2 by y. Now we have to check whether or which one of the following is a polynomial in one variable. So always remember the three necessary conditions that were on the coefficient, on the variable, and on the exponent or the power of the polynomial that we have done before this particular question. First of all, we have to see whether all of the parts do have a variable or a single variable or not. So let us suppose I am starting with the very first part. The very first part is 4x square minus 3x plus of 7. First of all, we can see that in all these terms there is only one single variable. So obviously it is a polynomial in one variable. But before that, we have to check the exponents. There is a condition on the exponents that the exponent should be a whole number always. So first of all, we can see that the exponents of the variable x is of the form power 2, power 1, or we can say 7 into x raised to the power 0. So the power or the exponent of the variable, again x, is nothing but a whole number. So we can see in this particular polynomial that each and every power or the exponent of the variable is nothing but a whole number, and the other thing is there is only one variable in it. So thus it is nothing but a polynomial in one variable. So what we can say at the end for the solution set of this particular example or the question is, yes, it is a polynomial. So the answer is yes, it is a polynomial. It is a polynomial in one variable, as there is only one variable x. There is only one variable x, and the exponents are all whole numbers, and the exponents are all whole numbers. As we can see in this particular part, each and every particular exponent of the variable x is nothing but a whole number. So our condition on the powers or on the exponents is all satisfied. It means that this is nothing but a polynomial in one variable, and the other condition is all satisfied, that the exponents are all whole numbers. So this is nothing but a polynomial in one variable. So let's just move on toward the second part. Second part is y square plus of square root 2. So we can see that there is only one variable in this particular expression, and one variable is nothing but y, and the power of the y is nothing but 2. The power or the exponent is nothing but 2, which is a whole number. And again we can say that root 2 can be written as root 2 into y raised to the power 0. It means that the powers again is nothing but a whole number. So hence it is satisfied. Hence all the conditions are satisfied that this is nothing but a polynomial in one variable. So yes, this is again a polynomial in one variable because the powers or the exponents are nothing but the whole number, and there is only one variable in this particular expression, which is nothing but y. So let's just move on further toward the third part. Third part is y plus 2 by y. So let us suppose I am solving this particular expression as y plus 2 by y can be written as y plus 2 into y raised to the power minus 1. It can be written in this particular formation. So y plus 2 by y can be written as y plus 2 raised to the power minus 1. So what we can explore or see over here, that the powers of the variables, they are not all whole numbers. Why so? Because the power of this particular variable is nothing but 1, but the power of this term, that is 2y raised to the power minus 1, it is nothing but an integer. integer. So hence at the end what we can say about this particular expression, that this is not a polynomial. It is not a polynomial in one variable. The reason being is because the exponents are not whole numbers. Because the exponents are not whole numbers. If the powers or the exponents are not whole numbers, then such kind of the expressions, they are not called as the polynomials. So hence at the end what we have concluded that the part 1 is nothing but a polynomial. Part 2 is a polynomial because both of them are satisfying all the conditions that do exist on the exponents or on the powers. But the part 3rd does not satisfy the condition of having the exponents as the whole numbers. So at the end this is not a polynomial in one variable. So I hope the concept of clearing out whether these are the polynomials in one variable or not is all clear to you. So let's just move on further and try out another question.